Dear students, in this video we are going to discuss the concept of a satellite. Satellite is a body which is revolving continuously in an orbit around a much larger body. Okay, so we have known the natural satellites, which are the moons of the planets. We know the artificial satellites, which are used in communication sector, which are used in this mass communication. The televisions are working, and so that's a satellite. Okay, so we are going to study how the artificial satellites are launched, like what we do that an object suddenly crosses the atmosphere of a planet and it starts revolving around that planet. We are talking about artificial satellites. Okay, so if you consider an artificial satellite of Earth, like what we do to that so that it just goes up in the air, it crosses the atmosphere, and then suddenly it starts revolving around the earth. So that's a concept, a full-fledged concept of launching a satellite. Okay, suppose this is earth, this is the center of the earth, this is the radius of the earth, this is the surface of the earth, and you choose a highest tower on the surface of the earth so that you can launch a satellite. Okay, so suppose you have a satellite, you have an object which is going to become a satellite. Okay, so you give it a horizontal projection. Like we have studied the concept of a projectile. We have known that there are two types of projection: horizontal projection, angular projection. Horizontal projection is the one where we give horizontal velocity. Angular projection is the one where we give the angular projection, right? So we just throw the object up to a certain angle. That's angular projection, of course. So in the horizontal projection, we know that if we give an object a horizontal velocity, it is going to travel a parabolic path and it is going to come down, right? And when the object comes down after following a parabolic path, it flies away from the original point from where it was fired. Like this will be the horizontal range. Suppose if you give more horizontal velocity, then the object is going to fall at a much larger distance than before. Suppose if you give more and more horizontal velocity, in the third case, the object is going to fall more away from the point, right? So this means if you keep on giving the more initial velocity, the object is going to fall more away, right? So the concept of launching a satellite says that if you have given enough of the initial velocity to the satellite so that it actually goes so away that it escapes the earth's gravitational pull, and its horizontal range is so much that it actually crosses the earth. Its horizontal range, it follows a parabolic path. Its horizontal range is so much that it crosses the earth, and then since there is no gravitational pull outside the earth, so it starts revolving around it. Okay, so this is principle of launching a satellite. Satellite will always try to fall on the surface of earth, but since the earth is spinning around its axis and it is revolving around the sun, so every time satellite tries to fall on the surface of the earth, it actually skips and it comes here. Again it tries to fall on the surface of earth, but earth is revolving, so it skips that, and it is actually always attempting to fall on the surface of the earth, but it is not getting enough chance because you had given it enough of the initial velocity. So this is principle of launching a satellite. Now it's the time to deal with the terms associated with a satellite. The first term that we are going to study is orbital velocity. So what's orbital velocity? Orbital velocity is the minimum speed that you should give to the satellite so that it starts revolving around the earth in a particular orbit. See, the orbit could be anything. Like this is the first orbit, this is the second orbit. Now it's up to you. Up to what distance from the center of the earth you want to place the satellite, right? So suppose I want this orbit to be my orbit of satellite. I want to put this satellite to this orbit. Okay. And capital R is the radius of the earth. This is the center of the earth. This small r is the radius of that orbit into which I want to put the satellite. So the orbital velocity of the satellite will be small v. Okay. Since the satellite is revolving around the earth, right? So it is doing that with the help of a centripetal force. Like it is requiring centripetal force to revolve around the earth. The magnitude of the centripetal force will be given by mv square upon r. Okay. So earth and the satellite are bound together because of the gravitational force. And that gravitational force is given by g, capital M, small m divided by the distance between the earth's mass and the satellite's mass. That's r square. After that, see, these two equations are one and the same thing. So gravitational pull only is providing the centripetal force. So you can equate these two, find out the value of the speed, okay, which is required to put the satellite in this orbit. Now we know that the relationship between small g and capital G is written like this. You can actually find out the value of gm from here, from this relation. It comes small g r square. Put into this equation, okay. What is small r? Small r is capital R radius plus the height above the surface of the earth to which the satellite has been put into the orbit. Suppose this much distance is h. This much distance is h. So capital R plus h is equal to small r. Right? That's what I've written over here. After that, r square should be taken out of the root and it will become r. Okay. Now when h is very, very less than r, this means the satellite has been put into that orbit which is very, very near to the earth. The satellite is orbiting the earth very closely. That means the height of the satellite above the surface of earth is negligible as compared to the radius of the earth. So h can be ignored as compared to the radius of the earth. So h is neglected here and you get this. Okay. This capital R can be written as root R into root R. One root R cancels with the other root R and you're going to get under root GR. This is the orbital speed when the satellite is orbiting the earth very closely, right? So this is the concept of a orbital speed. Basically, it's the minimum speed which a satellite requires to revolve around the earth in a particular orbit. Like you can actually choose the orbit to which you want to put the satellite into revolution around the earth, right? Now we have another concept which is time period of a satellite. Now time period of a satellite means the time taken by the satellite actually to revolve around the earth in one complete orbit. Okay. Like this is the earth, this is the satellite. What is the time taken by the satellite to take one complete round, one complete revolution around the earth? So of course time period will be equal to distance traveled upon orbital velocity, because time is equal to distance upon speed. Okay. So distance traveled is of course what? This whole circumference. And what is the value of circumference? 2 pi r. This small r is the radius of that orbit. Okay. Orbital speed is v. Now orbital speed, नॉर्मल वैल्यू ऑफ ऑर्बिटल स्पीड इज अंडर रूट जी आर स्क्वायर अपॉन आर. ये वैल्यू तब आती है जब आपने अभी तक वो कंसीडर नहीं किया होता कि सैटेलाइट अर्थ के बड़ा क्लोजली रिवॉल्व कर रही है. क्योंकि एक बार आप वो कंसीडर कर लेते हो तो आपको हाइट को इग्नोर करना पड़ता है. क्योंकि अगर सैटेलाइट अर्थ के बहुत क्लोजली रिवॉल्व कर रही होगी, दैट मीन्स द हाइट ऑफ द सैटेलाइट अबव द सरफेस ऑफ अर्थ वो तो नेग्लिजिबल है रेडियस के अकॉर्डिंगली. ओके, सो ये वो रिलेशन है जिसमें अभी तक आपने ये कंसिडरेशन नहीं की है. सो यू कैन यूज दिस इक्वेशन ओवर योर. v is under root gr square upon r. Okay, 2 pi r as it is. Take this. This becomes under root r upon gr square. Okay, so after that t is equal to 2 pi r. ये r square, take it out of the root. This is capital R, r by g. Now, when you take this small r inside the root, you have to square it. This will become r square. Because अगर इसको बाहर भी लेके आओगे तो वो r ही रहेगा ना. It's just a mathematical arrangement. So r square into r cube. But what is the value of small r? R plus h. So this is the value of the time period. But let us find out the value of the time period when the satellite is orbiting the Earth very closely. So small g is equal to capital Gm by r square. Take out the value of m from here. M is, this m is density into volume. Earth is considered as spherical, so volume is 4 by 3 pi r cube, density is rho. So put this value of m over here. You get the value of g after solving. Once you get the value of small g, this value is to be put here in this expression. Okay, this will become like this. And after that, take this 2 pi by r inside the root. When 2 pi goes inside the root, it becomes 4 pi square. जब चीजें root के अंदर लिखते हो तो square कर दो. Okay, and r becomes r square. Right? So after that, what is going to happen? Make the necessary cancellation and t is equivalent to this. Now if the satellite is revolving very closely to the earth, h can be neglected and this will become 3 pi capital R cube upon R cube 0. R cube cancelled. 3 pi by 0 is the value of time period. When you'll put the values of the constants, like pi is 3.14, g is 6.67 into 10 raised to the power minus 11. Rho is something 5500 or something, density of earth. Okay. So once you put the values, you're going to get the value of capital T equivalent to 8.46 minutes. So this is the time period of the satellite which is revolving very closely to the surface of the earth. Okay. सो हर वो सैटेलाइट जो बहुत क्लोजली ऑर्बिट कर रही होती है अर्थ को, उसको अप्रॉक्स 84.6 या 85 मिनट्स का टाइम लगता है अर्थ को एक राउंड पूरा करने के लिए, एक रेवोल्यूशन पूरा करने के लिए. सो दैट्स द टाइम पीरियड, राइट? नेक्स्ट वी आर गोइंग टू फाइंड आउट द हाइट ऑफ द सैटेलाइट अबव द सरफेस ऑफ अर्थ. दिस वॉज द एक्सप्रेशन फॉर टाइम पीरियड. ओरिजिनल एक्सप्रेशन जब तक आपने कंसिडरेशन नहीं की थी कि h इज वेरी वेरी लेस देन r. सो लेट अस टेक द ओरिजिनल एक्सप्रेशन. व्हेन यू स्क्वायर इट, यू आर गोइंग टू गेट 4 पाई स्क्वायर r स्क्वायर. ये रूट हट जाएगा एंड दिस इज गोइंग टू बी लाइक दिस. ओके, यू वांट टू फाइंड आउट द वैल्यू ऑफ हाइट. सो r plus h cube, keep it at one side and take the other stuff to the other side. Once you're done with that, you need to remove this cube because you need to reach to the value of h. So taking cube root on both the sides, this cube will no longer remain and this whole stuff will become 1 by 3. Now you want to find out the value of h. Take this r to the other side and this is the value of height of the satellite which is revolving around the earth in a particular orbit. Next is angular momentum of the satellite. Angular momentum is r cross p. P is linear momentum. P is written as m into v. So overall angular momentum is mvr. There v is a orbital speed. Put its value. Find out the value of angular momentum. Same way, now we are going to find out the energy of a satellite which is revolving around a planet. Potential energy plus kinetic energy will give us total mechanical energy. Potential energy we had derived in the last module. It was minus gmm upon r. Kinetic energy is half mv square. V is the orbital speed. Put its value and find out the value of kinetic energy and potential energy. Then take the sum. You're going to get the total energy. This is the last topic of this chapter, which is escape speed. See, escape speed is not about the satellites. It's about any object which is given a vertical projection. Satellite is given a horizontal projection. Escape speed talks about how much vertical projection you should give to an object so that it crosses the atmosphere of Earth and it never comes back. The Earth's gravity stops working on it. Okay, so that's the escape speed. Suppose what is happening? This is the center of the earth. Then if the object escapes the surface of earth, then in its way it has got 2 points P to Q. So let us suppose OP is equal to X. Let us suppose PQ is equal to DX. Now, what will be the force of gravitation between that object and the earth? It will be this. Okay, GMM upon X square. So find out the value of the work done when the object goes from P to Q. So that will be FDX, force into displacement. Since force and displacement are happening in both the directions, external force. So this will be the value of dW. Now you want to take that object out of the surface of earth. You want that the earth's gravity is no longer acting on that object, and that's why the name is escape speed. The object just escapes the surface of earth, right? So W will be equal to R to infinity, and just integrate it, right? When you integrate it, x raised to the power minus 2 dx, again you have to what you need to do, you need to apply the formula of integration, the same formula that we had discussed in the last module, x raised to the power minus 2 plus 1 minus 2 plus 1 r to infinity. So when you will solve it, you're going to get work done equivalent to this. Now this work done is is done at the cost of the kinetic energy, half mve square. You can compare and you can find out the value of escape speed. So escape speed is that speed which you give to make the object escape out of the surface of earth. Remember, orbital speed is about launching the satellites. Escape speed is a general phenomena, is a general fact when you say that you are giving something a vertical projection, and the projection is that much that the object never comes back to the surface of the earth. It escapes the gravitational pull of the earth. So that's escape speed. वो अर्थ से कभी ट्रेस ही नहीं होता, वो अर्थ से काफी दूर जा चुका होता. That's escape speed. Okay, so that way we have to carry out this derivation, and once you find out that work which has to be done by you to so that the object escapes, so this is that work done. Now that work done is actually converted to kinetic energy of the object when it is going up, and that's why it has been equated. That's why it has been equated with the kinetic energy, and ultimately you find out the value of escape speed. Thank you, and this way the chapter finishes with 5 modules. I'll upload the playlist of these 5 modules by the name Class 11 Gravitation. Okay, students, kindly post your doubts if any.